Hello, everybody. This is our first note day for virtual school for Algebra 1, and today we're going to be talking about graphing linear inequalities. Yesterday, you should have been practicing graphing lines, and we're going to use that skill again today. The other skill we're going to use is from when we were working with inequalities before. And remember, when we worked with inequalities, when we got an answer, we drew a number line. And then we put in either an open dot or closed dot on our number, and then we picked a side to shade. Well, we're going to do that today, only instead of shading a number line, we're going to shade half a graph. So instead of half of the numbers being our answer, half of a graph is going to be our answer. So we are going to get started. And before we can actually graph, the skill we have to practice is testing a point to see if it is a solution or not, so we know which way to shade. So we are going to check if a point is a solution. And so I do have extra slides so I can write down the examples for you. If a point is a solution to linear equality, when we plug in the x and y, it will make it true. So we're going to plug in our x and y, and we're going to see, does it make the inequality true? And if we get that it is, and we say yes, it will be in a shaded portion of our graph. And if we get the answer no, then it should be in the portion of the graph that is left unshaded. So I'm just going to click and we're going to do the first example together, which is 8 negative 3 a solution to y is less than 1/2 x minus 5? So I can use the drawing tool here. And when I use the drawing tool, just like having a whiteboard, I'm going to have to erase it once we are done. So what we're going to do is, since 8 negative 3 is a point, it's an x and a y. So we're going to plug those in for our x and y in our inequality. So negative 3 is our y, and 8 is our x. So I'm going to just substitute those values into our inequality. Now remember, when we are checking something, we don't try to add anything to both sides or multiply anything to both sides. We just try to make sure each side is as simple as possible. So starting on the left side, negative 3 is as simple as it gets, so I'm going to keep that there. But 1/2 8 minus 5 is not as simple as it can be. I can do some math here. So order of operations, say I multiply first. So 1/2 times 8 is 4. We still have minus 5. Negative 3 is still as simple as we can get. And then we can do 4 minus 5, which is negative 1. So now that both sides of our inequality are as simple as it can get, we're going to ask ourselves, is negative 3 less than negative 1? And in fact, it is. And we're going to say yes. So 8 negative 3 is a solution to this inequality. So if we were graphing it and we tested the point 8 negative 3, we would shade towards 8 negative 3. All right, so we are going to do the next example. So now that we have that erased, we can try the next example, which is 510 a solution to y is greater than or equal to 3x plus 1? So again, we're given an x and a y, so we're going to plug those into our inequality. So y is 10 and x is 5. So just like before, we're going to keep simplifying. We're not going to multiply or add or subtract anything from both sides. We're just going to simplify. So we're going to take our 3 times our 5, which is 15. Our 10 is as simple as it can get. 15 plus 1 is 16. So we have to ask ourselves, is 10 greater than or equal to 16? And in this case, the answer is no. So if we were using this point to test an inequality, we would shade away from 510, and 510 would be in the portion of the graph that is not part of the solution. And that's going to make a lot more sense when we actually graph them. So that's checking. All you have to do is plug in the x and y into the inequality and see whether or not it is a point by simplifying and seeing if it's true or not. All right, the next thing we're going to do is we're going to write down the notes on how to actually graph in a linear inequality. So I'm going to click this slide and I'm going to erase everything. All right, so here are the steps to actually graph a linear inequality. So I'm actually going to have you pause this video for a moment, and I will pause for your pause so that you can write this all down in your notebook, because remember, writing steps and doing steps help you learn things. So go ahead and write this in your notebook at this time. All right, so hopefully all of you have written this in your notebook. Like I said, if you need more time, just hit that pause button and write them down, because these are the steps we're going to use to graph linear inequality. So because it's a linear inequality, the first thing we're going to do is draw a line. Um, so remember, when we are graphing lines, we have to have our equation solved for y, because when we're solved for y, we can find a slope and a y-intercept, so we know how to graph. So make sure y is all by itself before doing anything. All right, we do have two additional steps. First one, we have to decide whether our line is a solid line or if it's a dotted line. So if we have a less than or equal to or a greater than or equal to symbol in our inequality, it's going to be a solid line, because all of those points on the line, when you plug them in, they're going to make our inequality true. So they're going to be part of the solution. Just like we had a closed dot when we had less than or equal to or greater than equal to when we just had one variable. When we have two, it's going to be a solid line instead of a closed dot. And then less than or greater than, instead of doing an open dot, what we're going to do is we're going to have a dashed line or a dotted line to show that when we plug in those points on that line, they do not make the inequality true. Now, like I said, our answer, instead of being half a number line, will be half a graph. So we have to figure out which half of the graph to shade. So we're going to choose a point, any point on the graph that is not on the line. It does not have to be 0, 0, but adding and multiplying by the number 0 is super easy. So checking the point 0, 0 when we can is a good thing to use. So when we plug in our point, if we get a true statement, remember that means it's part of our solution, so we're going to shade towards it. And if we get a false statement, that means that half of the graph is not part of our solution, so we're going to shade the other half of the graph. And that's going to make a lot more sense when we do this next example. So our example is y is greater than 2x minus 4. So first thing is our y solved for. Is y all by itself? It is. It's right there, all by itself. So the next thing we have to do is we have to graph the line y equals 2x minus 4, and we're going to make it dotted. And the reason we're going to make it dotted is because it is greater than. All right, so we're going to make a dotted line of y equals 2x minus 4. So remember, when we're graphing, we first find our b, and our b here is negative 4. So we're going to start at the point 0, negative 4, and we're going to put a point there. I don't know, why does that make a point? There we go. And then we're going to go here. That is a little wonky. So I'm going to... All right, so it's 0, negative 4. We're going to make a point. All right. And then our slope is 2 over 1. So we are going to go up 2. So 1, 2 over 1, and we're going to make a point there. All right. And, I like to do it twice, so up 2 over 1 more. All right. And then we're going to make a line, but we're going to make it dashed. All right. It's not a great line, but it is a dashed line. I did try to use a straight edge. I'm sorry that it is so horrible. So we graphed our line. I just need a little space here, so I'm going to erase how we graphed our line. So on your homework, I think you noticed there is a spot where it says test. So we are going to test a point, and since the point 0, 0 is right here and not on our line, I'm going to test the point 0, 0. So is 0 greater than 2 times 0 minus 4? Well, 2 times 0 is 0, and 0 minus 4 is negative 4. So is 0 greater than negative 4? Yes, it is. And because it is, we're going to, that means we found the half of the graph where our solutions are, and 0, 0 is on the top half. So when you have a pencil, you can just shade nicely, but we are going to shade this half of the graph because 0, 0 is on this half of the graph, and we got an answer of yes. So as you can see, we have a dotted line and we have half a graph. Now, any point you choose in this area would give you a true solution. So if I picked the point, say negative 1, 1, I would get 1 is greater than negative 6, which is true. So it's part of the solution. All right, we're going to try one more example, and then I'm going to call this video good for now. All right, so our last example, again, we have y is less than or equal to negative 1/2 x minus 3, so our y is alone. And so this time we're going to have a solid line because of this or equals to. So because of the or equal to, all the points on our line will be part of the solution. And so we just have to graph this line, negative 1/2 x minus 3. So my b is negative 3, and my slope is negative 1/2. So I'm going to start at 0, negative 3. And remember, the top tells me to go down 1, and the bottom we always try to go to the right. So 1, down 1, right 2. There we go. So I went down 1, right 2 in both directions. I'm sorry, those points are so horrible. But then we make, through those points, we make a nice solid line. Remember to go all the way through your graph, otherwise the shading part might be kind of hard to do because you can't shade everything because you don't have a line all the way across. So one more time, we are going to test a point. The point 0, 0 for me is right here. So it is not on my line, so I can use it to test. So in the part that says test on your homework, you'd put the point 0, 0. And then we're going to plug 0, 0 in. So is 0 less than or equal to negative 1/2 times 0 minus 3? We get 0 is less than or equal to 0 minus 3. And so we get 0 is less than or equal to negative 3, which is not true. So no, it is not true. So instead of shading up towards 0, 0, 0, 0 must be in the part where our solutions are not. So all the points that make it true must be down here. So we're going to shade this way. All right, so that's graphing linear inequalities. If you need any more help, remember there's a video there on Brightspace for you. There's a website, and you can always contact me via Remind or Google Meet, or just email me, and I will get back to you. I hope you are all safe, and I hope you're all healthy, and I hope you all have a great day.